Welcome to 2.1, what is a triangle? So today we're going to go over the basics. We're going to go over what a triangle is and how we can classify it, and some examples. So a triangle is a figure formed by three segments. Remember, a segment is a line that is bound by two ends, so it doesn't go on forever. You can see here's one segment, two, and three, with these three endpoints. So a triangle has three sides, three angles, so 1, 2, 3. Those are the three sides. In here are the three angles and three vertices. Remember, vertices are endpoints where two segments or two rays meet. So this would be the vertices. These would be the vertices. Now, how would you name them? Remember when we named angles, the ordering of the letters mattered. For example, if we wanted to name this angle, we would have to say angle BAC or angle CAB, because we needed the vertex to be the middle letter. Now, when you name a triangle, the order of the letters does not matter. So you can name this triangle ABC, triangle BCA, triangle ACB. It doesn't matter as long as you have all three letters. That's all that matters. Now, how can we classify triangles? Well, we can sort them according to their angles, to their types of angles. So first, acute triangles. This is when all angles are less than 90, and you might see it written as 45, 65, 75. This is just the measure of all three angles. And the next one is an obtuse. This is where one angle is over 90 degrees. As we get into 2.2, you'll see why only one angle can be bigger than 90. But for now, just remember that obtuse is over 90 degrees, and you can see it written as 150, 30. And a right triangle is where one angle is 90 degrees, and it's represented by this small square. And again, you'll see why in 2.2, why you can only have one angle in a triangle that is obtuse or a right angle. Now we can classify triangles according to their sides. So the first type is an equilateral. This contains three congruent sides. And remember, we represented congruency with these hash marks. A way to remember this is that equilateral, it's similar to the word equal. So you can think of all the sides being of equal measure. Now the second type is an isosceles. This contains at least two congruent sides. So you can see here, there are two congruent sides, but this side is not congruent to these two sides. Now, I highlighted at least because this means if you have three congruent sides, it's still considered an isosceles. So in other words, all equilateral triangles are isosceles triangles, but not all isosceles triangles are equilateral triangles. And a way I like to remember this is I look at SOS. These two letters, S and S, are the same, where the third letter is not the same. So that's how I remember at least two congruent sides. And lastly, we have a scalene triangle. This is a triangle that has no congruent sides. Okay, now let's look at this example. We want to classify the following triangles. So let's take a look at this one first. Okay, so is it acute? That means, remember, all angles have to be less than 90 degrees. Yeah, and they are. So it is acute. Is it obtuse? Well, no. If it's acute, then it can't be obtuse or right. It has to be, if we go back to these, it can only be one or the other. It can't be both of them. It can't be all three. So therefore, we can already cross out obtuse and right. Now, this is based on angles. Now we can look at it based on the sides. Remember, equilateral, they have all three sides are congruent, and you can see it is based on the hash marks. Now, is it isosceles? Remember, isosceles has at least two congruent sides. In this case, it does. So just because it's equilateral, don't rule out isosceles, because remember, all equilateral triangles are isosceles triangles, and it can't be scalene because it does have congruent sides. So that would be your answer. Now let's look at this triangle. Is it acute? No, we see this right angle here, so it has to be right, and therefore it can't be acute, it can't be obtuse. Now let's classify it based on the sides. Is it equilateral? Well, no. Remember, it needs 3 congruent sides. In this case, there's only 2. And what did we say has 2 congruent sides? Isosceles triangles. And it can't be scalene because remember, scalene triangles do not have congruent sides. So that's how you would classify triangles based on their angles and sides. So now let's get into what's called the triangle inequality theorem. This states that the sum of any 2 sides is going to be greater than the third. So let's pick 4 and 5. 4 plus 5, this is 9, and this is greater than the third side, which is 7. What if we picked 4 plus 7? This was 11, and this is greater than 5. And what if we pick 5 plus 7? This would give us 12, which is definitely greater than 4. So what type of pattern are you noticing? If we wanted to simplify this theorem, we can actually see that if you add 2 sides, it's obviously going to be greater than a side that is really short. For example, 7 and 5, they're already bigger than 4 to begin with. So even if we add it, it's expected that the sum will be bigger than 4. Okay, so really, if we wanted to simplify this theorem, we can say the sum of any 2 sides. Instead of saying any 2 sides, why don't we say the sum of the 2 shortest sides? It will be greater than the third, or we can, instead of saying the third, we'll say the longest side. Let me move this. 2 shortest sides, longest side. And you can see it's much simpler than if we had to add 4 plus 5, 7 plus 5, and 4 plus 7, right? Instead, we can just add 4 plus 5, which are the 2 shortest sides, to give us 9, which is greater than 7, right? Because we take the 2 shortest sides and see if it'll be greater than the longest side. If we took 7 and 5, which are the 2 longer sides, of course it'll be greater than the shortest side. So that's how we can sort of simplify the theorem. And we can apply this knowledge to example questions. So they're going to ask you, can these 3 segments form a triangle? Well, based on the theorem we just discussed, we can just take the 2 shortest sides, 3 plus 2, gives us 5. And this is not greater than the longest side, so your answer would be no. This can't form a triangle. It wouldn't be possible. And Apex has some exercises which will help you visualize it more easily. Okay, next. What could the length of the third segment be to form a triangle? Now in this case, you're going to have to go through each answer choice and apply it and see if it works. It's sort of like a guess and check. So let's pretend it's 3. Okay, choice A. So now the 2 shorter sides are 3 and 3, which gives us 6. And this is not greater than 12, which is the longest side. So 3 would not work. How about 6? Let's see. Well, now our 2 shorter sides are 3, 3, and 6, which gives us 9, which still isn't greater than 12, so this would not work. What if we tried 9? Well, 3 and 9 are still the shorter sides. This would give us 12. It is still not greater than the longer side, so 9 would not work. Now what about 11? 3 and 11 are still the shorter sides. This would give us 14. It is greater than the longer side, so 11 would work. Now what if we wanted 12? So now 3 plus 12, they are considered to be the shorter sides, the 2 shorter sides. This would give us 15, which is greater than 12, so this would work. And now try 16. So now it's not these 2 that are the shorter sides anymore, it's these 2. That's why you have to sort of apply it and check before assuming. 3 plus 12 gives 15, but it is not longer than the new longest side. I know this isn't to scale, but just pretend. So since 15 is not greater, this answer choice would not work. So only D and E could be possible measures of the third segment.